Well, so first I'm going to draw a plot to show the saturation point. So well, first insert plot, drawing, design, select data, x values. As x values I will get the input power to the amplifier. This is the right column. Fine. As e values I will get the column level 1 and of F1 and F2, which are our main tones. Accept. Okay, and here we can see a very nice saturation response. It's the typical one. I'm going to improve the graph. So first the lower x value I'm going to select 20 dBms, and the x, I prefer the x to be in the left side, so I will choose value axis value -20. So okay, I like more in this way. The title of the graph will be psat 1 dB. Fine. Next thing, well, titles, of course, because every graph should have the units in the axis. So this is P input power in dBms, and also the vertical axis will be P out. How can? Okay, fine. P out in dBms. Fine. Next thing I need is the line, the tendency line. I don't know. Well, I think it's here. That's it. Line linear, but oh no, this is not what I want, because this line has been done taking into account also the saturation part of the response. We don't want that, so I'm going to get exactly the values in which it is not saturated. So we can say that from 14.5 to lower values, or maybe 14.75. Fine. I will get these values. Okay, copy, paste. No, this page. This paste has been some strange. Paste values. Okay, this is exactly the same. Now I can draw a second series. Select data, new x values. Of course, only the ones in the linear range, the input powers in the linear range, which are these ones. Accept. Oh, well, of course, sorry. Yes, it's output power. Fine. Now in orange you can see a series only taking into account the linear range. So if now I draw the tendency line with this, exactly this is what I want, but of course I need to make this larger so I can see the saturation point. Maybe with 3 more steps, or yeah, 3, it's fine. Yeah, so here we have in this graph, well, I think it can be rescaled a bit, but there we can see the saturation point. Let's make it bigger. Yeah, in this way. Fine. Well, it's always good to make it nicer, but we can see here that the saturation point, remember it's the output power, it's around 15 dBms. I would say that's the saturation point. The manufacturer says the saturation point was 18 dBms, so okay, they say 18, we can see 16, so it's fine. We can be happy with our measurement. Now, in order to look for the interception point, we are going to draw another plot. As the new plot will have the the output power in the main frequencies, I will just copy the first plot that we have from the previous step. This is the same. I'm changing the title, and now I'm just going to plot, apart from the current curve, I'm going to plot also the power in the third order intermodulation tones. Input power is the same as always, okay, input power that column, fine, and the other column is the third order power level, fine, and we have here the two curves, okay, fine. Now I need the tendency line for the new series, okay. So I'm going to do the same as that I did in the previous step. I'm going to copy just the values which in which the amplifier is working, well, in this case not in the linear range, but the values in which the power of the third order tones is growing at a constant rate, okay. So it's more or less between -6 and -14 dBms. In this range, the power of the third order intermodulation tones is growing at more or less 3 dBs per each increment of 1 dBm in the input. So I'm copying just this range, fine, yeah, it is okay, and I'm going to do the same trick that I did in the saturation plot. I need first new series only for the linear range. This is the input, fine, and okay, this is the output, only that values, fine. So okay, and we can see now in the plot in yellow dots with the linear, the interesting points to draw the tendency line. Now I can plot it. You can see there. Now it's a lot bigger. Of course I need to extrapolate. Let's try with 5, for instance. No, in 5 I cannot see the crossing point. I need more, something more, maybe 9. No, more. I think. Well, maybe it's outside of the current area, and so need higher values up. Well, and also we can optimize the area, which is draw. Fine, 25 there, and I need to extrapolate more steps for the saturation point. And okay, we can see there the crossing point, which indicates the third order intermodulation tones, third order interception point. Fine, so we can see there clearly it's 25 dBms. Nice. I can improve a bit the graph so it can be seen better, and well, 25 dBms is fine. Nevertheless, if we go to the datasheet, the manufacturer says the saturation point is in 36.4 dBms, and we have measured 25. So well, maybe I don't know. Maybe the manufacturers are exaggerating somewhat. Honestly, I have never been able to get the same interception point as the manufacturer says. But well, they say for a specific frequency, probably with the best in the best conditions to obtain the maximum third order interception point. So well, we have obtained 25 dBms. It's reasonable. As I said, it's typical to measure lower values than the ones that the manufacturer said. So well, to sum up the conclusions of of the practice, we can say that we have learned what is nonlinear distortion. It includes saturation effects and the generation of intermodulation tones. We have seen that the nonlinear behavior of an amplifier can be characterized with the 1 dB saturation point and with the third order interception point. You have measured these two values for an amplifier to be specific for the ADL5545 from Analog Devices, and to measure that we only need a test bench with two signal generators to generate two frequencies quite close between them. Then we need also, of course, a spectrum analyzer to measure the different output powers for the main tones and for the intermodulation tones. We measured the output powers at these frequencies, and we have noted down the different powers in an Excel spreadsheet. Finally, with this data, we can plot the curves of output power versus input power for the main tones and for the intermodulation tones. And from these measurements, we have calculated graphically the saturation point and the third order interception point.